So now what we want to do is we want to talk about how it is that we go about proving that a function is one-to-one. That is, to use proof in order to show that the function is in fact one-to-one. Kind of understand the concept, right? Now we need to get to that next mathematical level where we actually go out and prove it. So we're going to remember first the definition. So a function is said to be one-to-one if and only if f of a equals f of b implies that a equals b for all a and b in the domain of f. So we're going to use that definition in order to prove that the function is in fact one-to-one, or to disprove that it is not. Okay, so first what we're going to do, the first step is to assume that f of a equals f of b. So let's take, for example, our example f of x equals 3x plus 1. All right, well, f of a equals f of b. Okay, that's our assumption. Suppose we'll let that be the case. Okay, let f of a equal f of b. Then we're going to set f of a equal to f of b using the equation. So that means that 3a plus 1 equals 3b plus 1. That's literally what it means for f of a to equal f of b. Then use some algebra, 3a plus 1 equaling 3b plus 1. We'll subtract 1 from both sides. That gives me 3a equal to 3b. And then we'll divide by 3 on both sides. And so a equals b. And then we'll finish it up. Thus, it is shown that f is one-to-one. Finished. So that's what we did. We assumed that f of a equaled f of b. Then we set 3a plus 1 to equal 3a plus b, 3b plus 1. Right? Then we used some algebra in order to show that a equals b. Finished. That's actually how you prove that a function is one-to-one. All right? Using algebra. Now, let's take a look at another example. We'll call this one example number 2. And we're going to use f of x equals x squared this time. And I'm going to actually show, so I got f of x equals x squared. Now, the best way to show this is use a counterexample. So, f of 2 equals 4. F of negative 2 equals 4. Okay, because f of 2 equals x squared, which is 4. F of negative 2 equals 4. So, 4 equals 4, but 2 does not equal negative 2. Thus, f is not one-to-one. Remember that in order to be one-to-one, we'll take a look at the definition again. In order to be one-to-one, it must be for all a and b in the domain of f. Well, 2 is in the domain of f for f of x equals x squared, and negative 2 is also in the domain of f, okay, right? But they map to the same element, so consequently, not one-to-one, all right? So, quick review, right? This one here probably a little bit more instructive for you. We'll assume first that f of a equals f of b. Then we'll set f of a to equal f of b using the equation, and then we'll show using algebra that a equals b. Now, if it turns out that f is not one-to-one, then all you need is just need one single counterexample to show that it is not. And that concludes how to prove that something is one-to-one.